Right, today we're going to look at parallel lines. We've looked at working out midpoints and gradients. And let me just have a quick look, see what else we've done. And equation of a line between 2 points. Okay, we've looked at the gradient and y-intercepts and identified those in the equation of a line. So now what we're going to look at is something similar where we use parallel lines. Right, what's interesting about parallel lines, and I will draw a quick sketch and try and explain it. Okay, remember a sketch doesn't have to be precise and everything, it just needs to have the rough understanding of what's going on. So we have our x coordinates and our y coordinates. So if we have a straight line, then we will have the gradient of a line, which is great. We know how to work out the gradient of a line when we're given 2 points. We've got our y-intercept, okay, so whatever that value would be. Now, a parallel line is quite interesting because it will never touch, let's call this one line 1 and this one line 2. It will never touch the other lines that are parallel to it. And what's interesting about that is they always have the same gradient. So if you're told that one line is parallel to the other, then you know that they have identical gradients and you can use the gradient of the line that you've been given, okay, to work out the equation of the other line. So parallel lines have the same gradient. Okay, so if anything to do with parallel lines, this is a really important point that you should really write down in your question, whether it be parallel equals same gradient. Okay, if you can write this down, then that will really help you. Okay, it gives anybody that's looking at your work and shows that you understand what you need to do, and sometimes that's all you require just to get 1 mark, even if you can't do the rest of it. Now, parallel lines will never cross. Okay, so if you figured out that 2 lines intersect at a certain point, then they are definitely not parallel, and you could prove that they're not parallel. Okay, so let's do a couple of examples. Example 1. Find the equation, I'll just do EQN, of the line parallel to y equals 5x minus 7, okay, that goes through the point 317. Right, if they give you something with a gradient, then you've got the gradient that you can use. If they give you a point as well, then you've got some coordinates which that line goes through, and you can use that to work out the whole equation of the line. So what do we know? We know parallel lines have the same gradient. Okay, so write that down. Parallel equals same gradient. And it shows that that you understand it. It shows anybody that's marking that you understand it. So what we know is the line that we're looking for, the equation of the line that we're looking for that's parallel to this line, y equals 5x minus 7, has the same gradient, which is 5. So go back to the general form of an equation, which is y equals mx plus c, and that we know m equals 5. So we can put that in, y equals 5x plus c. Now, we need to work out the c value. And to work out the c value, we use these coordinates. Remember, this is the x coordinate and this is the y coordinate. So if we substitute these 2 values into our equation, we should be able to solve it and find the c value. So y is 17, x is 3, so that's 5 times 3. and that's plus C. Okay, so 17 equals 15 plus C. Then to find out what C is, we take away 15 from both sides. And we're left with 2 equals C. So we found our C coordinate, so then all I need to do is replace this C with the number that I found. So the equation is y equals 5x plus 2. And that's your answer. Okay, sometimes they're not this straightforward. They don't just give you the equation on one point. So I'll do a second example, and then hopefully we'll be okay to go ahead and have a go at some questions ourselves. So, example 2. Find the equation of the line parallel to the line that joins 7, 3 and 3, 11 that goes through 6, 6. So find the equation of the line parallel to the line that joins these 2 points, and it also goes through 6, 6. So I used 317 last time because that was the point at which it went through. So once I've worked out the general form, I will use 6, 6. But they haven't given me the equation of the line. What they've given me is the 2 points that the line goes through. So I'm going to have to work out the equation of the line first, something that they gave me on its own originally before. So let's go back and remember how we work out the equation of a line between 2 points. First of all, we work out the gradient. So m equals y2 minus y1 over x2 minus x1. So let's label these. So we've got x1, y1, x2, y2. So y2 is 11, y1 is 3, divided by x2 is 3, x1 is 7. 11 take away 3 is 8, 3 take away 7 is minus 4. 8 divided by minus 4, so a positive divided by a negative gives me a negative. 8 divided by minus 4 is 2. So that's minus 2. So we've got a gradient of minus 2. So now we need to use one of these points, 7, 3 or 3, 11, and then we can work out the equation of the line that we're going to use to work out the equation of the parallel line. Actually, we don't even need to work out the equation of the line, remember? Because what do we need? We need the gradient. So the parallel line has the same gradient. So make sure you write down now parallel equals same gradient. See, I was going to go through and work out the whole equation of the line, but we don't need to do that. All we need is this gradient. And then we need this point. So what we know is y equals mx plus c. We have the gradient, so y equals minus 2x plus c. And we have the coordinates at one point at which this line goes through. So I'll substitute those coordinates in. Okay, so 6 equals minus 2 times 6 plus c. And then minus 2 times 6 is minus 12, so 6 equals minus 12 plus c. Add 12 to both sides. And we get 18 equals c. So now that I've got my c value, and I've already put my m value in, which was minus 2, all I need to do now is substitute in the 18 for the c. So the equation of the line that's parallel to the line that joins these 2 points is y equals minus 2x plus 18. Okay. Have a go at some questions. All right, see if you can do this. It's not that tricky. All you really need is the gradient. Okay, in both cases, all I needed was the gradient, and then I used the general form for the equation of a line. All right, have a great day, guys.